This tutorial is about rules in NLP++. This is an in-depth overview and does not cover everything, so I provide links in some of the passes for those who want to go deeper. It is important to understand that rule matching is not required in NLP++. I have written analyzers that match no rules and only use functions, but for the most part, rules are extremely useful, and this tutorial will go over the fundamentals. First, we're going to take a look at the rule regions, and there are 4 of them. There's check, pre, post, and rules. Check is exactly that. It'll check to see if this rule should fail or succeed on some condition. A lot of times this is a global condition. The preconditions, the pre area, is to check on certain elements with some characteristics. Does it have a header? Is the number 0? Is the number range this? Is it capitalized? The post area is what happens if you do match the rule. You execute what's in the post area, the code there. And finally, you have the rules themselves, which are a node, suggested node, and the parts of the elements of that node, that rule, which will, if match, will make this rule happen. Next, we want to look at the dictionary pass, or pass 5. Now let's look at what I call the compact form of a rule. You notice here we have one at rules, but we have many rules underneath that. And one of the reasons we often do this is for a dictionary-like lookup. That is, instead of using our dictionary mechanism, we will use a quick and dirty dictionary pass. This is oftentimes used to put in special words that are for this analyzer that we have to put in there. And it doesn't have to be quick and dirty. It can be something very useful, but we want to put lots of them in. The idea is to make them compact and easy to read, because it's sort of like a dictionary. Here you have a state. Of course, you could have all the states together and make in a big list like I do here. You have as, at, in, of, for prepositions, determiners. Here are some nouns, here's some adjectives, but all of these are under one of the rules. So anything underneath this, anything above it will apply to all these rules. You notice down here, I have rules, but I have a post area because I want to add something to it. Once I identify 3 as a number, I want to attach the number 3, the attribute, or the number to the underscore number attribute. So this rules has its own post. You notice this has a rules, this has a rules. So you can also write those in what I call compact form. Normally we don't do that because we normally want to have a number all the nodes in a rule. And so, but in this case, we want to keep it compact. Okay. So next, I want to tell you about what we call special rule elements, like start, exit, alpha. Special rule elements are underscore X and then all caps, and they can be used within a rule, and they match a certain class of something. If you want to get an entire list, a comprehensive list of all of the special rule elements, you can go to this link. But these are the most commonly used. The most commonly used are alpha, numeric, a wildcard, white, capitalization, capital letter. That means one letter capitalized, just a letter. The ones that are a little bit, those are pretty self-explanatory. The ones that are a little bit confusing often is X start and X end. X start doesn't match anything. It makes the next node required to be at the beginning. If you have all these siblings in a tree, imagine all the siblings at the same level, the next node will have to be the first in that tree. It's going to be the first of its siblings. The same way goes with end, but at the opposite end. If you have an end in the rule and you have something before it, this end will require that this particular node that's being matched must be at the end of the sibling tree, of the parse tree. Okay, so again, you can look at a comprehensive list. It's very important to understand. These are highlighted in yellow normally. The highlighter doesn't always work right, but that gives you a good idea of the special rule elements. So next, let's take a look at suggested modifiers. Suggested element modifiers are something that are very important to the matching algorithm of NLP++. For more in-depth information, you can go to this link that I have here. We're going to talk specifically about the single or singlet. What this means is that oftentimes the word like of is buried underneath some other node. For instance, we have a dictionary, and that dictionary says of, so it's going to match of before we get here, and it's going to put it underneath prep. Well, the problem is if we have a rule that we want to match of, which often happens in NLP++ analyzers, we have to have a special way of saying, look, don't just stop at the prep. We want to go all the way down and get the specific, the leaf. So it could be that of is under a parent, under another parent, under another parent, buried under just a stack of parents, just one tree, one direct tree, but we want that rule to go and find the of. So let's run this and see what happens. We're going to run this, and let's take a look at the tree that we get for this right here. So we can see that of is here, that the prep, we have a prep above it, and we still match. That still matches. You can see we've matched it. In fact, we can click on this and we can see we've matched it. Okay, but when we look at this rule, what's going on? How did it match of if in reality, if we look one pass above it, we don't have of at the top level. We are matching in root, yet we're looking for of. Of is no longer at the top level. So what do we do? Because oftentimes we want to do a specific match for that specific word. So that's why we have S. Now, if we take that S away, you're going to see when we look at this, that let's look at the pass for the suggested pass. You see that still matches. We matched it with the S. But now we're going to look at this tree. Let's run it again without that S and see what happens. Nope, it did not fire. You notice that no longer, it did not say, because it's going to look at root and it's going to see prep and of is buried. Oftentimes that's what we want to do. But again, if we don't want to do that, then we leave it like this. We run it and you'll see that in fact that gets marked. Now, base allows us to mark a base. That is, if something is nested, 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 we can mark prep as base to say never go below this. And also you can have unsealed, which is the opposite. If it's a base and you've sealed it up, you can still unseal it. So these are all things that have to deal with the suggested tree. Okay? All right. So let's go on now to the phrase modifiers. Now the phrase modifiers, there are quite a lot of those. In fact, you can take a look at them in this link here, and we'll talk just about a couple of them. We have min and max and all kinds of things, but those are more with the wildcards. So what we have is we have determiner followed by adjective followed by a noun, something like the blue house. But you can have the house. So what this allows you to do is you can match more than one thing. So let's go ahead and take a look at what we've matched. We've already run this on the text, and the text is already, obviously, I've set it up to combine with these rules. And you see that it gets, this one rule gets the happy lizard and the lizard. If we look at the tree for that, you're going to see down here, the happy lizard, determiner, adjective, noun, determiner, adjective, noun, or you can also see determiner, noun. Now the trig is something very useful. In a noun phrase, if you don't have a noun, you can't have the blue. That's not considered a noun phrase. It's got to have a noun. So what you can do is you can put a trigger in this element and it will match this first. It'll make it not only more efficient, but it will match this first and says, you know, you have to have that. So that's just a way of making it more efficient. There are sometimes that is necessary and it won't work without that trigger. But in this case, it's just to give you an example. So you will come across a time where this trigger will save you. You've got a rule and it's the only way it's going to match for you. All right. Well, that gives you an idea of just regular nodes, concept nodes that you're building, and you have optional trig. And there are others, but most of the modifiers, the phrase modifiers, are going to come with the wildcard, because that's where you have the power, but you can also get in trouble. So let's take a look at the wildcard. You notice they're supposed to be all in yellow, and yes, I have these actually as an issue in GitHub, but these should all be in yellow. So I do apologize for the Lexer. It gets mixed up when it gets these backslash characters, so we'll have to correct that. But let's take a look here at the wildcard, because that's what we're looking at now. So we're going to take a look at the text here, and we're going to see that what we have here are some wildcards for, you can see some what I would look like headers in markup language, whatever language, it's not important. But imagine these are headers, these are marking headers. So here you have a wild, a plus says match, and then the pound sign or the dash sign. So maybe you have dashes, you could have dashes in this text. But so you can have more than one, but this one will match plus. Now plus is like plus meaning one or more. So plus means one or more. You got to have at least one. Wild card, if you do not put plus in, it will match just an alpha. Wild card can be nothing. The only way you can avoid that is put one here, meaning match it once, or plus, meaning one or more. So that will require that there be a match. So this header requires that you have a pound sign, okay? So that's what that means. Here's another rule, the noun phrase. Remember the noun phrase adjective noun that we had in our phrase model determiner adjective noun? Well, what if we want to have more than one adjective, which can be the big blue burnt down house? Then you would have more than one. Or you could have the big blue house bird. Or the big blue ugly house bird. So you could have more than one adjective, more than one noun. So you notice here that I have a match and adjective. This match in this wild does not require that this exists. I don't have to put optional here. Wilds are always optional unless you mark them differently. So you can see here this says match an adjective or not, and match as many as you want. Wild will match and match and match and match. That's what a wild does. Now here you can see this is important. Now the trigger is very important because it's got to find a noun here. So if you don't have that in this plus, you're going to say, okay, well, it could just not match anything, and you could end up having just a determiner and adjective, and that again is not a noun phrase. So we want to trigger on this, make sure we get a noun, plus meaning more than one, and let's go ahead and take a look at these next sentences, the wildcards, what we've matched. So I'm sorry, I lost that there. There we go. Switching it around on you, going back and forth. But here's the rule, and here is what we've matched, okay? We've matched these, the funny blue moose and the funny blue moose lizard. Remember, we only had one adjective, one noun here, or one noun. Now we have two adjectives and a noun, or two adjectives and two nouns. So it's now much more productive. And if you look at the tree for that, you're going to see that, in fact, you're going to have the funny blue moose and the funny blue moose lizard. Okay, so let's go back to this rule. We're going to look at one more rule here, and that is the end sentence. Now, this is a real function that you can get from, I'm not going to put it in there, but you can get by going into the libraries and you go into formatting, you're going to see sentence enders. That's where I got this. So I copied that from that one and put it in here because it's a good example of wild, wild, wild. Now, if you put wild, wild, wild and don't put anything on it, it's going to blow up. It's not going to work. Or it's going to match one wild, and it doesn't make any sense anyways. The wild cards have to be put together in a logical matching way. For instance, this has one, and this has one. So this requires that this wild matches with these conditions of matching. It requires the second one, which has to match one of these, and the third one, which will then match one of these, white space, whatever. What is this saying? Well, the first thing it says, I'm a trigger, which means I have to match either a period, question mark, or exclamation point. And I can't just match any of them. This could be 1.5. This could be in the middle of a number. What we want to do is say, we want to match only when we have an alpha or a number and a dot and then an alpha. And yes, this will match on an alpha dot number if you take the spaces out. But if you make this rule, the one thing I didn't do was make this rule before the remove white spaces. Over here, we're moving white spaces so that the rest of the analyzer is going to be wonderful. But when we're looking at the wildcards here, I wanted to show you this. And of course, this would fail if you have 5.3. But this really should be put before a remove white space. And that's going to be another tutorial about white space. Okay, so when we look at this and we match, and we look at the matches for this, you're going to notice down here that we have matched some ends of sentences. We have once, and then exclamation point, then another word. So this shows, oh, that's going to be an end of sentence because I got something before and something after it, and that's the way we're doing the sentence markers. So you can see here in the angle brackets, it's marking what it's actually matching, and that's another very, very important part of this. And we'll talk about that in the post rule, and that is I am going to reduce, that is, I'm only going to put underneath the sentence marker 2. You can have it match all kinds of stuff, but you can then put, I want the end sentence only to be here, and leave these alone. In fact, if we look at the tree down here, we're going to see end sentence doesn't get the more, doesn't get the month, it gets just this period. And that's what this does in the post area. It says reduce this rule, but only reduce the second node. Okay? And you can see the end sentence here, best, end sentence, and then horse. So again, it matches best, it matches horse, but then it only reduces the second node. Again, if we look at this, we can see that there is horse is matched. It's in a smooth brackets, and best is in the smooth brackets. That means NLP++ matched it, but it didn't match it to reduce. The things that it reduces will be in angle brackets, okay? So I hope you understand that. Let's go on. The next pass we're going to look at is the post region. Now, the post region has a very important aspect of it that you must know from the very beginning. Let's look at Rule 1 and Rule 2 here. Rule 1, we have some matching nodes here with conditions, etc. And in the post area, we have no single. See this single? We have no single. And we have an X nil. In the second rule, we have a this there and a single. That's very, very important. If you have no single in post, when you have a post area, you cannot assume that this rule is going to fire and put everything under the suggested node. And in fact, it won't do that. If you don't have a single in the post area, it's not going to reduce it. So these things do not get put under a parent called X nil. Whereas this one will, because here are the nodes we're going to try to match. It has a single, meaning, okay, we are going to single reduce it, and those things will go underneath. Okay, so you also notice these numbers. If I put another word in here for this, you notice the numbers are not all numbered, so you can go down here and right click on and click and select reformat rule. And what that'll do is put these, they're just comments, 1, 2, 3, and 4. Now this is really important because when you're in the post area, you want to specifically target a specific node, like this node, the 3, and you want to set some attribute there, you have to be able to know which node it is. Is it the third node, the first node, the fourth node? So that's really important. This whole idea of keeping them like this instead of the short form like you saw in the dictionary, it's really important to do that. So we're going to run this. In this first rule, we're going to match, you notice this S, because S means that this is a node that's been matched before. I happen to know that. So match this one, alpha. And when we do that, we're going to put this attribute on the third one, and we're not going to reduce it. And this one, we're going to match that one, alpha. And yes, we are going to reduce it to this time and put this. Okay, so this one. All right, so let's run it. And let's take a look at that post area here. And we're going to see here what's going on, these first two. We're only looking at these two. The other ones are for the other rules. So we have this one here, this one here. You notice that it all smooth brackets and in green. That means it's matched this, and this, but it didn't reduce it. If you look at the tree here, you look at the tree that says this, where is it? This one here, you see that it's been, the rule fired here, but it did not put anything underneath. You notice the second one though has, you notice that this has taken the terminator one there, that one there, and reduced it to this. That's only because we put the single. You notice also, we also attach the attribute this time to this. So you see this has this one, whereas this third node in the rule gets this, but it's not reduced. Okay, very important to know what the difference of having a single there and not having a single there. Okay, now you can do even a more targeted reduction by reducing only a part of these. So what we have here in our third rule is a single reduce node 2 to 3. So we're going to take these two and put it under 2 and leave this where it is. Okay, so these two will be reduced. So single, 2, and 3. So when we match 1, which 1 alpha, we're going to reduce and put that under 2, and that will be left alone. Let's take a look at the matching, what we have as the highlighting. You noticed here that which is in smooth brackets in green, which means it matched, but we only reduced this. These were put under a node. And that's why this notation is very important under in the txxt files, which are showing the highlights. So let's take a look at the tree. And we can see that, in fact, you see here's the rule. We've fired on this. We've matched which. We've matched 2, 1. We've matched now, but we've only put nodes 3 and 2 and 3 under 2. So that's another very important way to do things. Now, what if we want to construct a node, a name that is related to something in this, that we want to put like a variable. We want to create the name for this. We can't just type it in because it could be matching different things. Well, we can do that. And how do we do that? So we're going to match anything that's an equal. Let's take a look at the text here. And so we're going to be matching this one with the equals. So we're going to have plus means one or more equals are going to be matched, and then an alpha. So that the only thing in this text that's going to match it is this. Okay, and then when we get this is a header. We'd like to put this as underscore experiment. Okay, experiment, if I can spell experiment. Well, we can't do that because what if I change this to moose? You can tell I like the word moose. I don't know why. It's a weird word. Okay, then we would want moose here. Well, how do we do that? Well, we can't do it by literally typing this in. Okay, so we put in just an x nil placeholder. Okay, let's put in experience back in there. All right, and what do? We go, okay, what we're going to do is we're going to create a word. We're going to take the second word. So that's what this is. Here, once we match this, we're going to take the text of the second node. That's the notation. This is the variable n, which I talk about in a tutorial. I talk about before this, the special variable $text will get all the text that's related to the second node. So this will get whatever's that text is there, whether it's experience, whatever it is, okay? And so that'll get experience. And then in the strings in NLP++ are very easy. You put a string plus another string and that concatenates it. So this local variable underscore is going to be underscore experience. Okay. Then we have another function that's related to this single, etc., and that is group. You can literally call a function group, which will group any of these together. So you say group, and you can say 1 to 1 or 1 to 2. In this case, I'm going to do both of them, 1 to 2, and I'm going to name that node that we're reducing called be whatever in this underscore. So this underscore local variable is going to have underscore experience or whatever else it would be. And so that will group 1 and 2 and reduce it not to x nil, but to underscore experience. Okay. And then we keep that node. When we do that, we get this node. So this is the suggested node. That's what group does. Okay. You can always right click on this and look at the documentation for it. And then once we get this node, we want to put some kind of variable on it and mark it as header with the value 1. That's just true. In NLP++, we don't have true and false. We have 0 and 1. So we have header, and we want to put on that. And that kind of the function for putting variables on parse nodes is this. Okay, you can look it up. That's going to be a whole different tutorial on parse nodes. Okay, so this, just take my word for it. What that does is it takes this node which is the suggested node, and you can add this to it. So let's run this, which we already have. We can then just take a look at what it's matched. Okay, there it's matched here. Yeah, remember these are from the other rules. The rule file can have many rules. So there that is. Now, most importantly, let's take a look at the tree for that. So here's experience, the tree, and you can see that we have matched these three. That would be matched with this. Of course, they're left alone. This is just a matching algorithm over here. It doesn't group them. You see that we have the word experienced. And you see that here we have experienced. If we, it doesn't put X nil. And again, that's because of this special function group. So that, again, is very important. And then you can see we put the, we can even put attributes on this special thing. This is something people like to want to do, and this is a very common thing to do. Okay? Next, we're going to take a look at the pre-region. There's a comprehensive list of pre-region functions that you can find at this link that I have here in this pass. But we're going to take a look at one that's very common, like in this case for dates, we're going to look at a year. Well, a year length should be 4, and its number range should have a range. If I put in something like 12, that's not considered to be normally a year. So what I put in here was the length 4, and in between a number range of 1700 to 1200. If you look at our text here, you can see that I have this date, March 12th, 1885. Now let's we'll run that, and we're going to take a look at the matching. In fact, it does match. We've matched the month, a number, optional comma, and then a number that fits that range. Now, be careful here. Don't edit this. This is not the text. This is the highlighting the text. You notice it opens up an Anna.00011.txxt. Make sure when you want to edit the text, you're editing the text. So if I put in 1669 and I save that and run this, and I go ahead and then click on the matching, you're going to see there is no matching. So again, we'll put this in 1885, and that's how you can use the pre area. You can use it to say, is it caps? Is it a number range? Does it have this attribute? Is the attribute equal to this? All of those things can be, you can see here in this action. It's not really necessary to go through them all. It's just important to know how they work. And of course, you can do any of the nodes, 1 to 3, 1 to 1, all of those things. But this just gives you an example. The rest you can use analogy. So the last region we want to talk about is the check region. The check region is sort of a global area. Once a rule fires, you got one more chance to say, no, I don't want it to succeed, or I do want it to succeed. And that's what the check is. You can say, for instance, here, normally it's a global variable that's been set for some reason. So if the people global variable is set, then you want to succeed because Fred is a person. But if you have horse here, it's not a person. And if you have the global variable people set, you want to fail in this case. So let's go ahead and run the analyzer and see what we have over here, because we have these sentences, and let's see what we've matched. In fact, we've matched Fred here, and that will be reduced as a person if you look at the tree. And we don't have horse. Now, if I go back to where I set that global variable, which is in pass 2, and I set that to 0, and we go back to the checked here, we should get this to fail and this to succeed. So let's run it and see what happens over here. Let's get rid of this here and run it and take a look at the, in fact, yep, it has matched horse. So again, the check area is simply an area where you can set up global checks and whether you want this rule to succeed or fail in some global sense. You may have a group of rules you want to fail under certain conditions. So I hope this has been a really good overview of the rules. Again, there's a lot of documentation, but this should give you a really, really good idea of how to use rules in NLP++.